Hey cultivators, this is a review and tutorial of the o2Grow oxygen emitter made by Oxygen Research Group and o2Grow.com. So this is their smallest home unit that's made for 10 to 20 gallon containers, and it has a couple of emitters that come out the bottom and that are attached to these cables. This is what they look like. It's an iridium based oxygenation electrolysis technology. And that was a mouthful. So this is my 10-gallon tank of distilled water, and what I did was I put a little bit of CalMag in it, so you can look up at my meter and see that it's got a couple hundred parts per million of CalMag in it. The reason why you have to do that is because the salt that makes up the CalMag is what conducts the electricity that causes the oxygenation. Now, if you haven't had an oxygen meter before, this is one thing that you're going to need to get. This will tell you how much dissolved oxygen you can get into your water. You're probably used to seeing these kinds of air stones like the one down in this bucket. Those will get your oxygen up to about what this meter is reading, 8.5 parts per million. So that's the maximum you can get with an air stone. But with the o2Grow unit, there it is, you can put the emitters in, and after 2 or 3 hours you can have 50% more oxygen. So we're looking to get this up to the 12.5 parts per million range in a couple hours. So the first thing I'm going to do is put the oxygen meter in the water tank down here to show you what the current oxygen level is. So it's in there, and we can look up and see that this meter is starting to drop. We'll see how low it goes here in a second. And you got to make sure not to use chlorinated water. In fact, they provide some dechlorination solution when they send you the device, because I think it creates salt or something like that if you use chlorinated water. So you either need to use RO water, distilled water, or use dechlorination solution. So I'm going to go ahead and put the emitters down in there. The other thing you don't want to do is run the bubbler like an air stone while the emitters are in there, and that's because the bubbles that pop up at the surface will actually bubble your extra oxygen right out into the air. So instead of a bubbler, you need to use a water circulating pump, and I have one right back here. You pull it out. Here we go. There it is. So I'm going to put that down in there, and then I'm going to turn it on. I got a nice little switch system up here. So now it's on, and you can start to see it moving the water in that container. And we can look up at the meter and see that the meter is already affected. Even though I haven't turned on the oxygenator yet, it changes when you put a circulator in there, because some of the water has more oxygen than other water in that same container, and that's kind of how it always is. So having the circulators in there makes sure that the oxygen gets distributed evenly throughout the solution. Okay, so it looks like we've settled on about 7.4 parts per million of oxygen. And so now we're going to go ahead and turn on the emitters. And we'll do that by plugging them in over here. And now we should be able to look down here and in here and see. I'll pull these up near the surface of the water so you can see the kind of sizzling mist that comes off of them when they are in action. Let me see if I can get the light shining in such a way so that that's fairly visible for you. There it is. It looks like heat coming off of it, but it's actually oxygen bubbles. So those come off as the electrolysis process unfolds, and the water circulating pump makes sure that it gets distributed evenly. Now, what we're going to do is we're going to go ahead and take a break from this video, and I'll come back in 3 hours, which is the time period that the company recommends the unit should run in a 10-gallon container, and we'll look and see how our oxygen reading looks at that point. Right now we're at 7.5 parts per million. Okay, more soon. Okay, cultivators, we're back 3 hours later, and we got 13.1 parts per million on the oxygen meter. So that's a full 50% increase from the maximum you can get from a traditional airstone bubbler, which is amazing. So if it is in fact true that more oxygen grows better plants, then we've got a winner here in terms of the product. I have just pulled the emitters out of the solution, which by the way is fine to do when they're plugged in. Even though they conduct a little bit of electricity, you can't get shocked by it. And I am going to unplug them now down here. And by the way, I have encouraged o2Grow to add a countdown timer into the product, but in the meantime I'm using this cheap and simple countdown timer from Amazon, so I can just set it on 2 hours or 4 hours and leave for the day and not worry about it running too long. The reason why they don't recommend running it for more than 3 hours out of a 24-hour period is, number one, it wears the unit down faster, and you'd have to get new emitters sooner that way. But number two, the water stays fairly well oxygenated for a while, and before we complete this video we're going to measure that. So I'm going to take a time measurement right now. I'll look at my clock and tell you that it is 10 minutes to 5 p.m. here, so we're going to come back in a little while and we're going to track how long it takes for this oxygen to dissipate back down to its baseline level. Now, while I have another minute here, I want to show you the next size up that o2Grow sells. This is, I believe, for 40 to 60 gallon tanks. So these are the two larger sized emitters, and they go with this box right here. Sorry, it's not right side up, but it's got a lot of circuitry in it and fans, and it's a nice unit. That one, I believe, is $300 more expensive than the little one, so you'd use it for a more commercial application. And they have even 2 or 3 sizes bigger than that that work with tanks up to 250 gallons. So check these guys out at o2Grow. That's the entry-level unit there, and the one we used today on this little tank of 10 gallons of water. And that's about it for now, so we'll just check in one more time in a few hours to see what the dissipation rate is like. We do have a slight drop here after just a few minutes unplugged, but still right around the 13 parts per million range. Alright, we'll be back soon. Okay, we're back 3 or 4 hours later, and the oxygen has dropped back down to the level it would be with an airstone. And that's a little disappointing. I've seen it drop slower in the past. So that got me looking into some of the variables that could be involved with the depletion rate, and I did learn a few things. For one, the water temperature of my 10-gallon tank when I was using a traditional air pump with an airstone attached was 74 degrees. Then when I switched it up to this circulating pump you saw earlier, which is a 25-watt pump, it raised the temperature a full 10 degrees, 84 degrees on a 10-gallon tank. So then I switched over to a 2.6-watt circulation pump, and we are now resting at 79 degrees. The reason why that's important is because as the temperature goes up, the amount of oxygen in the water is going to go down. There's a direct relationship there. So there's also an important piece of maintaining temperature with hydroponics because you don't want too much microbial overgrowth. So I think the low 70s is where you really want to aim it, meaning you can't use too powerful of a circulation pump and your room temperature can't be too high. And in that case, you're going to get as much oxygen saturation in there as possible, and it will deplete as slowly as possible. So that's where we're at with the review and the tutorial today. I hope you learned some interesting stuff, and I hope you get one of these units and start growing healthier, more productive plants. Till next time.